Hello and welcome to part 2 of the C programming course. In the previous tutorial, we learned how C works, how to compile the program, how to run the program, how the basic variables work, and we also created a for loop that enables us to understand how the char variable works. This for loop prints 1,000 times the char value, and after it prints it, it increases its size, its value. So as we remember, we run the program in the previous tutorial, and this was the output, which started with 0, which was the default state of the variable, and then it went up to 127 right here, because this is the maximum value that this char variable can hold, and once it reaches its maximum value, it goes down to the minimum value it can hold, which is negative 128, and it keeps running because we say add one and add one and then add one, and it keeps going. So it keeps adding one until it reaches 0 again, and from 0 it goes and keeps adding 1 until it goes again to 128, and so on and so forth, and repeats that process over and over again. So that's the case with a char, which has the values from negative 128 to positive 127, including 0 right here, which totals to 256 possible values, okay? Which are the number of values that 8 bits can represent. So that's it with char. As you can see, all of these variables right here are what are called signed variables, which means can hold both negative and positive numbers, okay? But now we will also learn about unsigned variables. So to create an unsigned char, we just have to write the unsigned keyword before the char. So if we create an unsigned char, it will represent the following. So let's avoid confusion and let's create an unsigned variable right here. So unsigned char, and I will call it I am unsigned char. Now set this to 0 again. Okay, so this unsigned char is also 1 byte long, so it's 1 byte, which is of course 8 bits again, so the same as char, but the difference is here. It goes from 0 to 255. So we have 255 plus the 0 number, which totals to 256 possible values that we can have. So this is an unsigned char. This means if we do this on a loop, it will cycle only between 0 and 255, and then it will go back to 0, and then again and again and again. So to check this, we will do just that in the loop. So instead of printing the I am char variable, we will print I am unsigned char, okay? And of course, we have to increment the same variable, so we're gonna print I am unsigned char, incrementing the unsigned char and also printing the unsigned char. Okay, so let's go to the terminal, and to clear the previous output, we want to type clear, and as you can see, everything is cleared. And right here, to compile it, we press /cc, and the program is compiled. And now to run it, we will press /c1. Okay, and the program has run right here. So if we go back to the first line of output of this C1 program, we can find that it starts with 0, which was the default number, okay? And it goes up and up and up and up, but as you can see, as you may notice, it goes past 127. It goes up to 255, as I told you, okay? Which is the maximum value of an unsigned char. So as you notice, this variable doesn't contain negative numbers. So only positive numbers, and of course 0. And okay, it reaches the highest value it can possibly store, which is 255. And then it goes back to 0, 1, and it goes again to 255, as you can see, and again from 0 to 255 again, and so on. So that's the difference between a char or char and an unsigned char. Okay, so a character can be used to store numbers, but it can also be used to store characters, single characters. Okay, to store a single character, what we will do is the following. So if we don't want to run a piece of code at any given time, we can just comment it. So to comment, for example, these lines right here, all the for loop lines, I will select them and then I'll press Ctrl// and the Visual Studio Code editor automatically puts double / at the beginning of each line. And if we want to uncomment this, we can also go again and press Ctrl/ again, and it's uncommented and commented and commented. Okay, great. So I want to comment them, of course, because I don't want to be running them right now, because I want to illustrate how can we store a character like a letter on a char. To do that, I will say I am char, which is the first variable we define, and I will change its value. So I will set its value to a character. Now, to set the value to a character, what I have to do is define the single character between single quotes. So I create 2 single quotes, and maybe I will press the character E. Okay, so that variable now stores the uppercase letter E. Now, how can I print that letter? So there's a different process of printing it. So we'll still use the printf function, but in this case, we instead of writing %d, we will write %c, which means a character. So, which tells the compiler, please treat this as a letter and not as a number. Okay? So, if I print this, then I print a new line, then a comma outside the double quotes, of course, and here I write I am char. We end the line with a semicolon. Okay? And now I will run the program. So compile and run it. So clear, in order for you to visualize, /cc, /c1, and as you can see, the E character is printed. Now, some of you may say, what will happen if instead of telling it to print a character, I still tell it to print a number? Okay, so the I am char variable will still contain the E letter, but everything in the computer is represented as numbers. So if I tell it to print the number instead of the character, what will happen? Okay, so if here I put %d instead of %c, what will happen? So let's check. So we compile the program, we run the program, and as you can see, it prints the number 69. So why? Well, that number is the ASCII value that represents the letter E. Okay? So that's how this works. So what happens if we do the opposite? So remember, this is 69. What happens if we fill if we put in this character the 69 number, and then of course if I print it as decimal, it will print 69. Okay, so let's just test it, and it prints 69. But what if I print that 69 as a character? So if I put %C, so let's check. We compile, we run, and it prints E, because 69 is the ASCII code for E. So what happens if I go 70? The next ASCII code, okay? F is printed, because F goes after E in the ASCII codes, okay? But that's uppercase. What, maybe we want a lowercase letter, okay? So the same, we will print an E right here and lowercase e, but instead here we will print a decimal to check what the E ASCII code is. So you can say CC and then C1, and the lowercase letter e is 101. So these are just ASCII codes that were defined long time ago in a kind of a specific way, which doesn't have to make sense, okay? But some of them are ordered, okay? So what we will do now is to make a little experiment, okay? What we will do now is try to print all the ASCII values we can, but we will transform from numbers to ASCII values. To do that, we will set the I am car to 0 again, which we don't really need because the default value, as you can see right here, is already 0. So we don't need to do that. But now we will create a for loop. Okay, so we're gonna go and say for int I equals 0, colon, semicolon, I less than maybe 100. Okay, we don't want to print that many, and I plus plus. Okay, so this is how the for loops works. I have explained how the loop works in the previous tutorial, and inside this for loop we will write a code that will enable us to understand the ASCII values. Okay, great. So you can say print f, and we'll print a character, so %C, and then a new line, \n, and comma, and we'll print I am car, or I am char, however you want to pronounce it. And after this, we will increment the I am char variable, I am char plus plus. Okay, so what this will do is we'll print the 0, but not as 0, not at 0, but as an ASCII, the ASCII code of 0. Okay, so let's run it. So we compile it, we run it, and we have lots of letters printed, as you can see. So, and when we start, we have almost nothing. Why do we have this blank space? Because I think from 0 to the 30, there is no ASCII code, because they weren't defined. So, and then it starts, here is where the ASCII code starts. 1, 2, 3, 4, 5, 6, 7, 8, 9, colon, semicolon, greater than, or less than, equal, greater than, question mark, at, ABC, uppercase. So it starts with uppercase. Okay, it goes to Z, then goes with these brackets, slashes, these symbols, and then it will start with A, B, C, and so on. Since we are just printed 100, then it stops here. Okay, so that is how ASCII works. Okay, so pretty easy, right? So we've learned how ASCII works. We've learned also how unsigned variables work. Okay, so why we don't did the same with these other values? Well, because these are very long values. We can do it with short, you know. to showcase how short works. But these other two are very, very long ones that it will make the computer print lots of millions of numbers, actually billions of numbers, okay? Which are not worth it for now or for us right now. So, but we have to know that for every of these, we have its unsigned counterpart. So we have here I am unsigned char. So I think we can delete these guys right here because we won't need them for now. So we also have unsigned short. I am unsigned short. Okay, have unsigned int. I am unsigned int 0. So it's a good practice to initialize variables to 0, right? And we also have unsigned long in this case, which is I am unsigned long. Okay, so these are the basic integer data types, okay? But what operations can we do with these data types? So, of course, we can do additions, subtractions, multiplications, and divisions. And we can also do modulus operation, which returns the remainder of a division. So to showcase that, we will do the following. Okay? So we will print f percent %d \n, comma. And here, for example, we can say it to print the addition of two variables, for example. Okay? So we're gonna create here an int, which is kind of the most used data type in any programming language, not only in C. So int, and I'll say n0 will be to 1001, okay? And then create another int, it will call n1, and this will equal to 1002, okay? Doesn't really matter. And now maybe we'll call int m2, and this will be equal to n0 plus n1. So this is how we use addition in C. So the first variable stores the first number we want to add, which is 1001. The second variable stores the other number we want to add, which is 1002. In this case, the third variable stores the addition or the sum of that two previous variables, which is n0 plus n1. And now if we want to print the result of that sum, of that addition, we will go and say printf %d \n and n2. Okay, so we will run the app to check if it works. tc c1, and the result is 2003. Okay, which is awesome. So that was addition. Now, what if I want to do subtraction? So I change the plus sign with a subtraction sign. And I go again and compile it by saying cc c1, and the result is -1, because 1001 minus 1002 is -1, which is awesome. Now, If we want to multiply these two, we're gonna put the asterisk is the symbol to do multiplication in C. So I'm gonna put an asterisk and we will get the result. CC dot slash C1, and the multiplication of this number is 1,003,002, as you can see. Now, what if we want to do division? So division is a forward slash, as you can see right here. So we go and say CC C1, and the result is 0 because we're dividing a number by a larger one. Okay, so if we divide, for example, 1,000, and we will divide it by 4. Okay, so we will check how division works in a more descriptive way. So CC C1, and the result is 250 because 1,000 divided by 4 is 250. Okay, so that's how we work in C. Now, I also told you that we have the modulus operator, which returns the remainder of the division. Okay, let's stick with division for a minute, and we will do 10 divided by 4, right? So if we do 10 divided by 4, we set 2, but 2 times 4 is 8. But this is integer division, so it's not floating point. So if we want to get the remainder of that division, we can also maybe, okay, let's test with 10 divided by 3, which will be 3. So if we test it, it will be 3. But if we want to get the remainder of that division, which in this case is, 3 times 3 is 9, and 10 minus 9 is 1. So it will be 1. To get the remainder, we use the percent sign, which means modulus operation. So which means n0 modulus n1, or 10 modulus 3. And if we run this, we will get 1, which is the remainder of the division. So we have addition, subtraction, multiplication, division, and modulus operator, which are the basic operations or arithmetic and mathematical operations that we can do in C. Those are built in the language, and we can do them pretty easily. So that's it for integers. But now, what if I want to get the exact result of a division? So if I divide 10 divided by 3, I want to get 3.3333 and so on. How do I get it? How do I use that? Well, to do and get that, we will have to use floating point variables. Okay, so let's create a comment right here, and I will type floating point variables. What are floating point variables? Were variables that enables us to use floating point and decimal operations. Okay, the first most common floating point variable is called just float. So the same as a char, as a short, as an int, as a long, but in this case it is called float. And float, I will call it float. I will set it to 0. Okay? But since it's a floating point variable, I can maybe set it to 0.5 if we want. But sometimes the convention is to end it with an f, so I can set it to 0.5 f. So this variable needs 4 bytes to be stored. So 4 bytes. Okay? So let's try to print a float. Okay? So how can we print a floating point number? Okay, so let's go and say printf %d, because the decimal, okay, and of course I have to put this in double quotes, so %d I oh no, %d for \n, so the same we were doing previously, nothing new. I am float, and let's see how it prints out. So compile it, and here we have a warning which says, warning, format specifies tab integer but the argument has float. Okay, so we have to specify it as a float, so even here it gives you the new thing. So this is how the compiler tells you that something is wrong in your program. So to fix it, we'll go back, and instead of a D, we will put an F to say, well, this is a float. Okay, awesome. So we go and compile it again, and now, as you can see, no warnings appeared whatsoever. So if we run the .c1 program, we have our floating point value right here, which is 0.5, and we have 6 decimal points right here. So the precision of a floating point variable is exactly 6 decimal points. We don't have more when we don't have less than that. So that is how a floating point variable works. This means that now we can actually perform the operation we wanted. So we're going to say that I am float will be equal to n0, which is 10 up here, okay, divided by n1, so 10 divided by 3, as you can see, and we will print that value. So now if we go and compile this and print it, we can see that we have 3 right here, but why does it print 3 even though 10 divided by 3 is not 3, is 3.3? So why it doesn't print the correct number? Well, because it doesn't know, so this operation doesn't know that it will be stored in a float. So it doesn't know. So how do we tell it that, hey, we have a float, it's okay if we store it as a float? Well, we have to cast it, which means kind of translate to variable types. And for that we write a parenthesis and say float, and also we enclose in parentheses the operation we want to cast. Okay, and let's see if it works now. And as you can see, it still doesn't work. Why? Well, because the result is already 3 on .0. We have to cast both variables, right? So to cast both variables, we're going to say float, and then we will enclose in parentheses the n0 variable right here, okay, divided by, oops, what I'm doing, okay, divided by also another float, which is cast to float, and 1. So parenthesis float and 0 divided by parenthesis float parenthesis and 1. So now we will run it again, and as you can see, we have the desired result, which is 10 divided by 3 is 3.33333. Okay, so we're able to actually get floating point results with these floating point variables. But what you will say, if I don't want to do this, can I just define n0 and n1 as float? And the answer is yes, you can. So here we will define it as a float. So we're going to say float n0, I will call it f to differentiate between the previous one. I'll set it to the same value, which is 10. And then we'll call it float and one f, and I will set it to what was it, 3. Okay, so to make my life a lot easier, I will set I am float to n0f divided by n1f. Why I don't have to cast here? Well, because these variables are already float, so we don't have to translate. We had to translate previously because it were integers, and we wanted to translate it to floats, but now we don't have to because they are already floats. So let's now run it again. So compile, run, and as you can see, it still produces the correct result in a way easier format. Okay, so that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye.